Python tutorial, we will be fitting multiple Gaussian on a scatter plot using Scipy curve fit. Okay, so we'll see how a Gaussian looks like. So a Gaussian distribution uh, looks like in this mathematical form. It's 1 by sigma root 2 pi, which is called its amplitude, and then exponential minus half x minus mu square by sigma square. So mu is basically your mean where the Gaussian peaks, and sigma is the spread in that Gaussian from the center. Okay, so the thing we are going to do will look like this. You can see there are like three Gaussian scatter plot: blue and orange and green color are the data points for the scatter plot, and we have fit for their data points. So we have fitted three Gaussian in a single plot. Okay, so same thing we have to do using Python coding and model used called Scipy curve fit. Okay, so let's do it. Okay, so first of all we'll import necessary library. So first we will import numpy as np. So import numpy as np, then import matplotlib dot pyplot as plt. Okay, and then two things we have done. Now we will do some plotting. Okay, so this is like deals with array, and this deals with plotting. Now we will define some distribution looks like Gaussian. So you can say here x1 equal to, you can define some x-axis np dot linear space, and you can give your start number, end number, and number of points. Okay, so now we will give her y1. So y1 you can give as, say, y1 equal to 100 into np dot exponential, then you can give a minus x1 minus, say, 5 square, and then divided by 10, right? So this will be as, then plot it. So plt dot scatter x1 comma y1. Alright, so this is your like Gaussian plot. Okay, now what else you can do? You can also make it 20. Yeah, so this is your Gaussian plot, right? So let's add some noise in that. Okay, so for that I have this random module. Okay, so type here np dot random dot ran int, and give some like a starting number, ending number, and number of data points. Okay, so I will give from 1 to 20 and 50 data points. I mean equal to the number of data points in X size. Now plot it. Basically this should be called here, not the plotting. Now, okay, so here you can see there is like some scatter in that plot, I mean deviation from original plot. So it has added some noise. Okay, so basically your y1 becomes y1 equal to your y1 and plus your y1 equal to, so this becomes, so basically y1 equal to your y plus noise. Now we have to like do multiple plotting so that we can fit the three plots, not a single plot. Okay, so similarly you can define your other also, and just put here x2 and here y2, and then you can put here x2, then you can put here 200, you can put here 115, then x2 y2. Now you got a second plot. So similarly you can also plot a third one. So define your x3, your y3, you can make it 300, and you can make it here 20, maybe you can make it here 6 or 7. Then we have x3 and y3. Now okay, you got your three plots, right? Now what we have to do, we have to like plot, I mean we have to fit these lines together on a Gaussian fitting, right? So I will fit Gaussian together on a scatter plot, right? So we have done the plotting, and now we will fit a scatter. Okay, so for that just go here and from Scipy dot optimize, there should be Scipy dot optimize import curve fit. Okay, so this is used to fit curve. Now for fitting, so we'll like define a Gaussian. Okay, so define Gaussian profile to fit, right? So for that you can define as a definition function and call it as a Gauss, and then you can give your amplitude, right? You can give your mean, and then you can give your standard deviation, and you can also give your x. So, and then you can return your profile. So return profile, you can return profile as a into np dot exponential minus x minus m square by and you can also give here s square and you can give here minus half into, right? So this way you can define your profile. Now so here basically your a is your amplitude, your uh, m is mean, and s is your standard deviation, right? So we have like three parameters. Now we'll fit it. So fit using Scipy curve fit, right? So we have like multiple, okay? So for single, what we do, we type like POPT and P covariance, equal to curve fit. We pass our function, then we give our, you can say what it takes. So basically it takes your function x data, y data, and your initial guess, right? So you can just give here Gauss, your x data, your y data, and those things, okay? But like we have three things, so we have to do it using loop, okay? So use for loop. So for that I will go and type here for y in, so like we have three sets, okay? So y1, y2, and y3, right? Similarly for x in, x1, x2, and x3, right? So I will now here fit, okay? So this will like, so here POPT is your optimize parameter, and P covariance is your 3 cross 3 symmetric matrix, and it finds error in fitting, right? Now this much we have done. Now we'll try to plot, okay? We'll try to plot the fittings. So plot fitted Gaussian. For that type plt dot plot, and then give your x data, and then give Gauss your x and you can give your a star POPT, right? And here you also like need to give your initial value P0. So P0 equal to, you have to define an array for that. So you can say P, and P you can define as P equal to, so P equal to, you can define as say 100, 5, 1. You can define P1 200. So this is like your initial guess of your 5, 1, and P2 you can define 300, 6, 1, right? So for that we have to also like use a new loop. So for P in, so for P in, P, P1 and P2, right? So basically you, yeah, so basically you can call it P1, 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 P2 and P3. Now you have given here, so your P0 you can write, so your P0 is initial case for fitting three parameters. Now you have to show this plot. So type here plt dot show, and also you can do here, you can type here plt dot figure for new figure and run it. What is the mistake? There should be comma, and you need to go here. There should be P1, P2 and P3. Now you can see that here you have like plotted three Gaussians occurring from the fitting. Now you can put all these plots in a like a single. Okay, so put type here. So go from the loop and type here plt dot scatter x comma y and run it. So here you can see that got your three plots, right? Maybe you can zoom it, so you can add here a percentage matplotlib widget. So here you can see that you have plotted your curve on the scatter line, right? Now what I'll do, I will so I don't have use of this, maybe you can leave it like that. Now you can also give label, so you can give label here. So give here label equal to, you can say data and go here and type plt dot legend. So maybe to go out from the loop. Okay, so now it's fine. Okay, so now what I will do, I will like obtain its parameter. Okay, so and write on the plot. So for that, type here level equal to it, you can type here fit such that your a value, and you can give as a float dot to second decimal places, and same for everyone. You can call it just, you can give your mean, you can give your standard deviation, and then you can give as a percentage tuple and pass your POPD together. Now run it. So here you can see that you have got a level for your data, and for your first fit, second fit, and third fit, right? You can also print if you want to. You can print here. Print you can take here. So for that, type here take a square root of diagonal of p covariance, and so you can type here np dot sqrt, right, and then np dot diagonal, then p covariance. Now okay, so you got here, and you can type here string and error in A, M and S respectively, right. Now print it. Okay, so you got here is the appliance parameter for first error, and then for the second and for the third. Okay, so this way you can obtain your optimized parameter and your error in that, right? So I hope you got the idea that how to fit these lines on Gaussian plot. You can also customize this plot if you want, or maybe this is fine. So I am expecting that you have learned that how to fit multiple Gaussian on a scatter plot using Scipy curve fit, right? So I can give a title here, plt dot title multiple Gaussian fitting. Okay, so got here. You can also increase your size if you want. Is equal to 150. You can do. Maybe you can put it 100. Right. So this way you can fit Gaussian on multiple scatter plot. So this is the code. So basically I don't need right now these things in the multiple plotting. So here can be the code once again. We have like matplotlib, numpy and random library. We have 3 plots, and we have added noise using random module, and then I have fitted using Gaussian profile on these 3 scatter plots. So I have obtained optimized parameter, p covariance, and I have given some initial value, right? P0 is your initial guess for the fit. Then I have here in that, and I have obtained these parameters. This is my fit, and it is looking nice. So thank you.